Hello, my name is Mohammed Lamin Jahate, and I'm in Professor Minman class, and I'm about to perform Lab 4. So the goal of Lab 4 was to build a microprocessor. So we had to build, in order to build a microprocessor, we had to build different circuits, which are right here in my Lab 4 folder. And at the end, this was my microprocessor. Let's just test it and see how it works. If we simulate it right here, so we're gonna take the address at the value 1 and just add it to the microprocessor. Keep going, and then at the end you can see we gonna get the value 8. So we had the value 3 and 5, so it works perfectly fine. After this, we had to export it into a Verilog file and visualize the wave, but I had to visualize 4 other waves, which were the N, the sub, the zero, and the ACC waves. So I just have the wave of my microprocessor right here, um, which worked perfectly fine as we wanted. So after that, we had to work on these different waves that I just talked about, which were the ACC wave, the N wave, the sub wave, and the zero wave. So first, we're gonna start with the end wave, which is right here. So if you visualize it, so we had to add 3. We had to add 3 and 5. So the result is going to be in binary, and it was a 4 digit binary number, which is represented by 1, which is 8. So 5 plus 3, which is 8. We could also see it over here if we visualize the RAM files for the end. So we loaded the accumulator with the value 3, then we add 5, then we stop, so we had the value 8. After that, we could visualize the sub wave. So I'm just going to close the end wave. So the subtraction wave, so so in my example, I just subtracted 5 from 3. So I had 3 minus 5. So if we do 3 minus 5, we're going to get 0, 0, 0, 1. And we're going to have its 2 complements. So at the end, we should get a hexadecimal value of 14, which is E. So that's what we expecting when we visualize the wave, which is what we get over here. So 3 minus 5 is going to be negative 2. If you convert it to binary, you're going to have to get its 2 complement and then get the value in hexadecimal, which is E over here, which is 14. Okay. So after that, we also built the zero wave, which just zero everything. So we just expecting a value of 0 over here. And finally, we had the ACC wave, which just leave the value into the accumulator. So if we just visualize this, we just gonna have the value 3 on the wave signals. So this was basically Lab 4. So we had a fully functioning microprocessor, and we performed different operations, which was AND, subtracting, zero, and these were the waves. So thank you.